Hello everyone. In today's lecture, we are going to discuss about Archimedes Principle. Now till now, we have seen what was the force or what was the pressure due to the liquid inside the container. That is P equals to rho g h, isn't it? Now, rho g h was the pressure due to the portion of the liquid which is at height h from the surface, from the first surface of the liquid, okay, from the upper surface of the liquid, whatever is the height, and if the height is increasing from the upper surface, the pressure is increasing. We know that. Now what if we make other objects to get inside the liquid? What is the force or what is the pressure that will be experienced by those objects if we put in any objects inside the liquid container, okay, or inside the liquid or inside the fluid? What is the pressure experienced by that? Now suppose in our daily life example, when we put some objects on any inside any liquid, either that object will float or that object will get immersed in the liquid. Now why is that? Why is that is happening? I mean, what is the reason behind it? Okay, so the thing is, when the object is put inside the liquid, okay, when the object is put inside the liquid or the fluid, it experiences upward force or upward thrust, okay, and that depends on the density of the object which is put inside the fluid. Okay, if the density is more as compared to the density of the fluid, then it will get immersed. For example, your iron, suppose there is one iron ball and one there is your plastic or rubber ball, okay, iron ball and plastic or iron ball. So iron ball will sink in the water, but our rubber ball or plastic ball will not sink. Why? Because the iron has greater density as compared to the fluid and rubber has lesser density as compared to the fluid, right, or the water. So this was our daily life example. Now let us see what is that force called. Okay, so when a body, let us state the principle first. Okay, Archimedes principle states that, or it states that if a body fully or partially, okay, fully or partially is immersed, okay, in a fluid, it experiences upward force, or thrust, okay. It states that if a body fully or partially is immersed in a liquid or a fluid, it experiences upward force, okay. Now this upward force, this upward force is called as force of buoyancy, or buoyant force. Buoyant force, okay. Now if a body is immersed in a liquid fully or partially, it experiences upward force or thrust. Okay. This upward force is called as force of buoyancy or buoyant force according to Archimedes principle. Clear? Now we will see what is that force. What is that force that is exerted by the fluid on the object or the body which is immersed in it. Okay. Now, as you can see the picture over here, so there is a weight of 5 kg, and as you can see in the spring balance meter, it can be shown that it is 5 kg, right? So still the weight is in air, okay, is in air. Now what we do is, in the next scenario, we put that or we lower that weight into the liquid, Now the reading in the spring balance will change from 5 kg to 3 kg. Why? Because there is one buoyant force, as you can see in the, it is mentioned in the picture, there is the buoyancy, force of buoyancy, the upward thrust, the upward force acting on the weight over here. Okay. So as you can see, the buoyant force is acting on the weight in upward direction, its weight decreases and there is reading in the meter, as you can see, it is 3 kg. It means the force, because weight is also force, weight W equals to mg, that is force acting downward, we know that, and force of buoyancy, let us write FB, force of buoyancy acting upward. So these are the two forces. So what is the equivalent amount of force which was acting from downward, that it has decreased the weight by 2 kg? That is equals to 2 kg. Previously weight is 5 kg acting downward. So force of buoyancy will be now 2 kg amount of force of buoyancy, that is 2 kg is decreased by the force of buoyancy. Okay. So as you can see, 5 kg acting downward, 2 kg acting upward. So the total net would be 3 kg acting downward. Net or net force, upward force minus downward force equals to net force acting downward. That's why in the spring balance meter it is shown as 3 kg. So I hope you understood that. Now let us see mathematically what is force of buoyancy and how it is expressed in mathematical form, right? So as you can see in this picture, 5 kg is now weighing as 3 kg and the rest 2 kg can be, means you can see it comes out, because when you lower the weight in the liquid, okay, when you immerse the weight inside the liquid, the amount of liquid which comes out, previously whatever is the volume of the weight, when it gets inside, that amount of volume of water gets outside, okay, and that weighs 2 kg. So let us see how, okay, let us see how we express this. Okay. Now force of buoyancy FB is given by rho Vg. What is rho Vg? Rho is the density. Let's mention over here only. Rho is the density of fluid in which the weight is immersed. Okay, density of fluid. Okay. V is the volume. Volume of the object. Okay, volume of the object. Okay, V is the volume of the object. Now if V is the volume of the object, rho is the density of the fluid, and G is acceleration due to gravity, this is the force, that is force of buoyancy, which acts in upward direction on the object. Okay. So force of buoyancy rho Vg. Rho is the density of fluid, V is the volume of the object which is immersed in the liquid, and G is the acceleration due to gravity. You already know that. Now what I mean to say is, what if force of buoyancy is equal to weight? Okay, we'll see that first let me complete this. Okay, force of buoyancy given by rho Vg, force of buoyancy given by rho Vg. Now tell me one thing, if V is the volume of the object which is immersed inside the liquid, can we say V is the amount of the liquid or the fluid which gets displaced by the object? Of course. Now see, as you can see in these two pictures, previously the level of the liquid is still the knob from where the liquid can come out, right? Now as soon as the weight of 5 kg is immersed, some liquid came out. It means what? Whatever volume of the object which is immersed in the liquid, that amount of volume or that volume of liquid gets displaced by the weight. So what can we say? V is also volume of liquid, isn't it? Liquid displaced by object. Can we say that? Yes, of course we can say that. Okay, volume of liquid displaced by object or volume of the object, both are same thing. Okay, so volume of the liquid displaced, so this V can be written as VL, that is volume of the liquid displaced or volume of the body or object. Okay, so this V is nothing but volume of the liquid displaced or volume of the object or the body immersed in the fluid. I hope that is clear to you, right? So why I am saying fluid sometimes, why I am saying liquid sometimes? Because this force of buoyancy is also valid in air. Okay, so air and liquid both comprises, both makes fluid, isn't it? Because example for fluid is nothing but liquid and air, liquid and gas or water and air. Okay, so volume of the fluid, volume of the body, both are equal if the body is completely or partially immersed in the liquid or the fluid. Okay, so force of buoyancy is given by rho Vg, that is nothing but rho is the density of the fluid in which the object is immersed completely or partially, fully or partially. V is the volume of the object or V is the volume of the fluid displaced by the object, and G is acceleration due to gravity. I hope that is clear to you. Now let us see how the density of the object affects the force of buoyancy. Okay, because in some cases you can see the object floats, in some cases the object floats but it is immersed completely, still floats, but some objects are floating on top of the surface of the liquid, some objects are floating getting immersed but still floating, isn't it? And some objects are there which gets completely immersed, that is it lies on the bottom, at the bottom surface, isn't it? So what is the difference between all these things? We'll see now. Okay, now as you can see, there are different objects, first cork, second wood, third iron, fourth watermelon, right? So in the first case, cork, the density of the cork is lesser than density of the fluid, that's why it is floating, which is immersed partially. Okay, more buoyancy force, you can say that like that. Okay, because buoyancy, the weight will be acting downward. This is our weight mg, isn't it? This is our weight mg acting downward. This is our force of buoyancy acting upward, isn't it? Force of buoyancy acting upward. Now tell me one thing, if the force of buoyancy is lesser than weight, the body goes inside, right? What if the force of buoyancy equal to weight? Then the body floats, isn't it? What if the force of buoyancy is greater than the weight? That doesn't mean that the body will be flying up when you put the body inside the liquid. Okay, so the thing is that the force of buoyancy, okay, equals to mg. In this case also it floats. If Fb is greater than mg, in this case also the body floats. But if Fb is less than mg, then body will be immersed partially or completely. Okay, if mg is greater than Fb, then the body sinks completely, as you can see in the case of your iron. So in case of cork, as you can see, positively buoyant. Positively buoyant means the job of buoyant force is to make the body go up, upward force, by applying upward force. So as you can see, force of buoyancy is greater or equals to mg for the case of cork. In case of wood, F of buoyancy, force of buoyancy is still positive. Okay, positive buoyant, positively buoyant, that is still positive, that is force of buoyancy is equal to or greater than mg. But in case of iron, the weight is greater than the weight is greater than or greater than force of buoyancy. Therefore, it sinks completely and it lies on the bottom of the container containing the fluid, right. But in the fourth case, as you can see, watermelon is means balanced. The weight of the watermelon is balanced by the force of buoyancy. The weight of the watermelon is balanced by the force of buoyancy. So, it will be immersed completely, but it will be lying inside. I mean, it won't be lying on the bottom, okay, lying on the bottom. It won't be lying on the bottom. So, neutrally bind. Neutrally bind means the force of buoyancy would be equal to mg, okay, that is force of buoyancy equal to the weight of the object or the body. So, it seems like the body feels weightless inside the liquid, okay, it floats but inside, completely immersed, okay. I hope that is clear to you, right. So, let us solve some problems based on Archimedes principle, that is force of buoyancy. Now, as you can see the question, a body of mass 2 kg floats in a liquid. What is the buoyant force on the body? Now, in the question itself they have mentioned it floats in a liquid. So, floats in a liquid means force of buoyancy is equal to the weight of the body, isn't it? Force of buoyancy is equals to weight of the body and mass is 2 kg. So, mass 2 kg and what is g? That is nothing but 9.8 meter per second square, isn't it? 9.8 meter per second square. So, what do we have? 19.6 kg meter per second square, that is nothing but 19.6 Newton. This is our force of buoyancy. I hope you understood that, right? Now, let us see another question. As you can see the question, a cubical block of copper is immersed completely in water. Each edge of the block is 1 centimeter in length. Find the buoyant force acting on the cube. The density of water is 1000 kg per meter cube. Okay. So, now force of buoyancy is given by mathematically, force of buoyancy is nothing but force of buoyancy FB equals to rho Vg. We know this, right? So, a cubical block of copper is immersed completely. Completely means the cubical block is completely inside the liquid, okay, or the water. So, density of the water is given to you, that is 1000, isn't it, in SI. And what is the volume of the cube? So, it is a block actually. So, cubical block means all sides same, 6 faces. So, volume is nothing but L cube. So, 1 centimeter means 1 into 10 to the power minus 2 meter. So, volume means L cube, isn't it? Volume of a block is L cube, you know that. So, we have rho V. Now, G value is 9.8, isn't it? So, what do we have here? 1000 means 10 to the power 3 into, over here we have 10 to the power minus 6 into 9.8. So, what do we have? That is 9.8 into 10 to the power minus 3, isn't it? This is the force of buoyancy. So, here we can write 98 into 10 to the power minus 4 Newton. I hope you got that, right? So, force of buoyancy acting on the cube of copper which is completely immersed in the liquid or the water is nothing but 98 into 10 to the power minus 4 Newton. So, that was all about Archimedes principle. Thank you.